Now that we're talking about macroevolution, there's a couple different ways that evolution can actually look at this scale, and it's not what you would expect. Now we're going to talk about the tempo and mode of evolution, or the pattern and process of how we think it happens on this large scale. Here we're looking at a bunch of different trilobites. Remember, there were many different forms of trilobites. They were super successful organisms that existed for millions of years. So we're talking about the tempo and mode. This means we're talking about the timing. Is it fast or is it slow? But also the process. Do we think this process was gradual or did it happen in sharp increments all at once? Here are two graphs, and these are showing these two different ideas. Over here on the left. That is phyletic gradualism. And phyletic gradualism is the idea that populations gradually change in a direction, and then maybe the population might split in two, and those populations just gradually change in different directions away from each other. So that shows how one species might split into two. On the other side, the right hand, we have something very different here. This is called punctuated equilibrium. First, you might notice that there's one population that kind of stays relatively consistent over time. That's kind of that white line there. But you might notice each generation, that bell curve shifts a little bit. It's always shifting a little bit back and forth. And that actually matches what we think happens with microevolution. There's just small changes, and that incorporates the ideas of genetic drift. But all of a sudden, we have this big jump, and now we have this black population that forms out of that white population. But after that initial jump, we just see small fluctuations. So phyletic gradualism, this hypothesis is that there is slow incremental evolutionary change, but it's always happening. Punctuated equilibrium, on the other hand, hypothesizes that now we have rapid bursts of change followed by relatively long periods of stasis. Phyletic gradualism was actually championed by Darwin, so it's very gradual change we can believe in. But actually now punctuated equilibrium is a better explanation for what we observe in the fossil record. But let's look at a different example just to help us understand what's going on. So here's a different graphic. Now we're looking at butterflies. So on the left, now we have our gradualism or phyletic gradualism here. And we can see that we have butterflies that look one way and they just gradually transform into these two different butterflies, but small gradual changes in different directions. In this punctuated equilibrium model on the right, now we start with that same ancestral model, but our ancestral morphology. That actual morphology is consistent and it still exists today. And then we have sharp jumps where we get these two other morphologies. And this is actually a much better match for the data we see in the fossil record today. There are some instances where we do see phyletic gradualism, but it does tend to be much less common. What it does tend to match with is in periods where the geology and the environment tends to be relatively stable, the species are going to be relatively stable as well. And when there's periods of rapid geological and environmental change, that's when we're going to see that punctuated equilibrium happen and lots of change in the species themselves. So here's one of my very favorite quotes from the authors of the theory of punctuated equilibrium. The history of any one part of the earth, like the life of a soldier, consists of long periods of boredom and short periods of terror. So this was written by Stephen J. Gould and Niles Eldredge, and this really matches really well with what we see in the fossil record. We see the same forms over and over and over. Oh, still the same. Oh, and then all of a sudden, there is something different in the fossil record. Apparently, these guys weren't particularly nice people. So some people like to call punctuated equilibrium evolution by jerks. So of course they hit back and they describe phyletic gradualism as evolution by creeps. So if these analogies help you understand the differences between these theories, this is a great way to think of them. Remember, punctuated equilibrium does seem to be a better match for what we actually see in the fossil record. I highly recommend you check out this paper, the original paper from 1977 by Gould and Eldredge, describing punctuated equilibrium and how it matches really well with the fossil record. So can you explain? What is punctuated equilibrium?